Welcome to the Explainer. Okay, today we are going to completely shift your baseline paradigm of reality. We are diving into the absolute latest mind-bending findings in the unified dynamics framework. Specifically, we're looking at that highly anticipated bridge from Appendix A to Appendix B. Get ready, because we are about to look at the universe not as a vast physical space, but literally as a cosmic computer.
Here is our roadmap for today. We're going to cover 1. The illusion of smooth space, 2. The ultimate capacity limit, 3. The origin of motion, 4. How debt actually creates gravity, and 5. Testing the cosmic network.
All right, let's jump straight into Section 1, the illusion of smooth space, and how we are redefining the baseline. To really grasp what unified dynamics is telling us, we kind of have to throw out the classical idea of how the universe is built. For over a century, general relativity has told us reality is built on continuous space-time, a smooth, curving physical fabric. But the unified dynamics framework proposes something entirely different. It argues that the universe is actually a discrete, digital-like network of tetrahedral nodes known as the K4 substrate. It's built entirely on pure combinational logic, completely replacing the idea of smooth space.
Let's move on to Section 2, the ultimate capacity limit, or essentially, the universe's processing cap.
Now, if the universe is a digital network, how does it avoid a localized system crash? Well, we literally have to look at the math, specifically this highly specific fraction, 7 over 768. In unified dynamics, the total macroscopic capacity fraction of a sealed K4 structure is 7 over 192. When you distribute that across the 4 internal symmetric vertices of the graph, you get exactly 7 over 768. This is the mathematically derived, absolute per-vertex topological capacity limit. Simply put, it is the ultimate cosmic speed limit for data.
To understand why that exact limit is so important, we need to talk about processing burden, denoted as B of V. Basically, this is the quantitative accumulation of unresolved state updates at a specific, discrete node. Think of this processing burden kind of like your computer lagging and freezing up because you have way too many browser tabs open. It is the network's algorithmic debt just piling up at a single microscopic point in the substrate.
So the crucial takeaway here is that the universe has a hard mathematical cap on how much processing debt a single coordinate can actually hold before the whole system shears. As that computational debt creeps up to the 7 over 768 boundary, the network actively alters its local admissibility field. It literally halts inbound state updates to prevent a structural collapse. But of course, it has to do something with all that queued up information, right?
Which brings us right into Section 3, the origin of motion, and these algorithmic fail-safes.
So what actually happens when the network hits that universal data limit and has to push the queue outward? The framework defines this exact mechanism as mandatory spatial diffusion. This is the algorithmic transfer of localized burden across adjacent K4 complexes. When a node nears that 7768 limit, the topological diffusion pressure essentially skyrockets toward infinity. The system forcibly acts like a massive load balancer, and here is the absolutely mind-blowing takeaway. This outward routing pressure is exactly what we experience in reality as kinematic motion and repulsive Pauli degeneracy pressure.
I mean, think about it like this. The framework explicitly states that kinematic motion is not a property of an object moving through some background void. Not at all. It is the algorithmic transfer of localized processing burden. The reason your hand doesn't pass right through your desk, it's not because of some invisible physical force field. It's actually because the universe's network has hit its data limit right at those exact coordinates, and it is algorithmically pushing back to prevent a system crash.
And the spatial diffusion, it doesn't just scale smoothly. It builds this incredible rhythm. The math shows us that it parcels out this computational debt in a strict 1-2 breathing sequence to create stable motion. Step 1 is asymmetric expansion, where the burden is forced outward across 3 faces of a stressed vertex, transitioning by a discrete multiplier of 4 over 3. Then, step 2 is symmetric consolidation, where that routed burden successfully locks into a full bipartite edge connection with a multiplier of 3 over 2. This alternating step function is what mathematically guarantees that data is transported without breaking the entire network.
Okay, let's look at the macro scale in Section 4. How debt creates gravity, or what we can call the macroscopic illusion. If motion on the microscopic scale is purely just data routing, what happens when billions and billions of these K4 nodes interact on a massive planetary scale? The answer here is just profound. Gravity is literally just the universe routing data toward unresolvable debt. In unified dynamics, there is no smooth space-time pulling on you at all. Instead, what we perceive as gravity is merely a topological trajectory bias.
Let's break down how that macroscopic illusion actually works. While isolated vertices exert infinite repulsive pressure when they hit the capacity limit, the macroscopic behavior creates a statistical counterforce. The transition probability for sequential updates is structurally biased toward nodes that have a high discrete burden deficit. It creates what we call an entropic routing gradient. So data updates are just probabilistically drawn toward massive clusters of unresolvable debt, like a star or a planet. When you zoom out, this purely discrete trajectory bias perfectly, and I mean perfectly, mimics the continuous space-time curvature of general relativity. Gravity is just data flowing toward a deficit.
Finally, let's get to Section 5, testing the cosmic network and the falsification trap.
Now you might be sitting there thinking, okay, this is wild, but is it just an abstract math trick? Well, the architects engineered this framework to be rigorously verifiable, absolutely no hidden parameters allowed. To prove this wasn't purely hypothetical, they ran a massive, bare metal discrete simulation called the F6 falsifier, using 800,000 samples, and they found this highly specific number, a 94.07% topological closure rate.
Why is that closure rate such a massive deal? Because it occurs strictly at the n=7 boundary. At an index of 6 or lower, the simulated network remains a totally unclosed computational vacuum. But hit exactly n=7, and bam! The system successfully bounds and structures the data. This incredible statistical jump effectively acts as a discrete Big Bang. It successfully triggers the network and resolves that pre-generational vacuum state purely through combinatorics. No continuous equations, no external curve fitting, just math.
Because unified dynamics relies on pure combinatorics, it makes exact zero-parameter predictions. By mapping out these observational benchmarks, we can actively prove or totally falsify this digital grid. For instance, if we ever discover fundamental point particles exhibiting continuous structural integrity above the Planck energy scale, the framework is instantly invalidated. We can also look for quantized steps in the cosmic microwave background. And crucially, using next-generation gravitational wave interferometers, we can look for overtone truncation and delayed echoes. If those future instruments achieve a signal-to-noise ratio over 100 and do not see the exact 1.8% amplitude deviation predicted by these discrete limits, the theory is dead. It is highly, highly testable.
I'll leave you with this final provocative thought. If motion and gravity are not fundamental physical forces, but instead are just algorithmic fail-safes designed to clear processing debt from a discrete combinatorial network, are we living in a physical universe, or are we just data inside a cosmic computer? I strongly encourage you to look deeper into the unified dynamics framework and explore the mathematics for yourself. Thanks so much for joining me on this explainer.